Hi, this is Roland Klaus from Dr. Klaus Incorporated. Today I want to show you how to join several point clouds together to form one big uniform point cloud. So what we have are 10 different single point clouds, different single scans from the same construction site. We can load the first of those point clouds in CloudCompare, a free and open source software. And we change the visualization of the grayscale values from intensity to scalar because it's much better visible. So as you can see, this is just one single location, one single setup, scanning the surrounding. We can make the point size a little bit bigger so we can more easily and more clearly see the scan of the surrounding. So here is our construction site, and as you can see we have a lot of shadows caused by small hills, small stockpiles on the construction site. And to have those stockpiles and those small hills completely in our laser scan, we did several locations, several setups with the laser scan. And to have them in one big point cloud, we have to join them together. So what I do is I take that first point cloud as our reference, and I load the second point cloud and align it to that first one. So now I have two point clouds loaded, and as you can see, they do not fit together. You can see from top, and as you can see here, very clearly, the second point cloud, which is this one, does not fit the first point cloud, which is this one. So we need to align them, and as I said, the first point cloud is taken as a reference. The second point cloud will be aligned to the first one. We can do that by using similar points inside those two point clouds, like here, for example, on that housing. We have that house in the second point cloud visible, and we have it also in our reference point cloud here on the left. So we use that similar points to just join those two point clouds. To do that, we select those two point clouds by using the control button on the keyboard and selecting the second one. And now we use the align tool, align by picking similar points. And here we can swap what is reference and what is aligned. And so we choose to use number 00 as reference and number 01 as the to be aligned point cloud. All right. So first we only want to see the reference cloud. And we go in. And for example, we can take here a point on that building. We can increase the point size to have a more clearly look. And so we choose a very clearly identifiable point, which is, for example, here on the side of that house. This point, for example. So this is now our first reference point. The coordinates are here shown in the window in that table. And so we now go in the other point cloud and select the same point. So it was here in the house on the left side. So this should be here, same point in the second point cloud. All right. And now you can see, if we take a look on those two point clouds, we have RO and AO. And those two correspond now together. So these two coordinates should become the same coordinate in our destination space. And the destination coordinate space is our reference coordinate space. So what we need at least are 3 such couple of points. And but this is mostly not enough. From my experience, we need at least 4 or 5 such pairs to have a very good alignment. So what we do now is we add more points to our reference cloud and then to our to be aligned cloud. So for example here that house is also very clearly visible. Let's take a reference point, go to our to be aligned cloud, and select the same point. Just have to clarify which is the correct one. This is sometimes a little bit difficult to identify the correct points. So, but it should be this house here. All right. And for example, we can take points here. You should distribute those reference points very equally around the surrounding, because as more widespread and as more distributed those points are and the more far away they are, the more accurate they can be used. So now as we have 3 points, 3 pairs of points, we can do a first referencing by pushing the Align button. And we can now see our result. And the first result is already pretty good. As you can see here, we now have those 2 point clouds pretty good pre-aligned, so that we can now add some more points to make it more and more accurate. So let's see, we have a big building up here in the backside. So we could use that building for doing a referencing also. So let's take the edge of the building. Should be here. And if you push a line again, he now tries to make the wool error between all pairs of points as low as possible. And always keep that checkbox unchecked, so he never tries to scale your point cloud. It is absolutely a bad idea to adjust the scale, because in that case all measures and everything inside your point cloud will be scaled, and this is not necessary, and also this will destroy all your measures and all your point clouds. So never get that box checked. This is absolutely important to uncheck that. All right, so let's add, let's say here, a pair in the backside. Maybe it's possible, maybe it's necessary, maybe not. I don't know, just I add it right now to make it as accurate as possible. So we add here another point in the backside, which is here. And we align that again and get a much better result again. All right, so this should be enough for right now. And we now have 1 point cloud, or we have aligned those 2 point clouds to form 1 point cloud. We can reduce the point size right now, and as we can see, yes, we can now accept the changes and the alignment and the transformation. And now we have those 2 point clouds aligned. So first point cloud was not moved. First point cloud remained at the position where he was, and the second point cloud is now aligned and completes the view a little of the first location. Well, controlling the view here in CloudCompare can sometimes be a little bit difficult. So you should play around a little bit before using CloudCompare, because it can sometimes be a little bit, yeah, a little bit irritating to move around here. So you need to get used to that. And now we can add the next setup, the next location. Just we plug, we drag and drop it in, and we make the second point cloud invisible. And as we now want to arrange and align the third point cloud here. So this is the third one. As you can see, it's pretty bad aligned. It does not fit in any case. So we need to align that again. Before you align the point cloud, I always take a look on the point cloud itself to see the quality of the points, to see what was actually captured and how it's currently located, and so that I can more clearly understand what I'm currently aligning here. All right, so let's start with that point cloud again. We now select those 2 point clouds. And again, we use point cloud 00 as our reference point cloud and point cloud 02 as our to be aligned point cloud. All right, and same game again. So we now select our reference points. And for example, we can again go with the houses here in that backyard. So let's select a few points here. First point, and now we go to our second scan and select the same point here again. Again, we can increase the point size to make it a little bit more clearly visible. All right, first point selected. Let's go to the next one. You can also, if you want, you can also first select your second point, so the A1 in that case, and afterwards select the reference point. It doesn't matter in what order you select that points, as long as it's clear to understand what is your reference and what is your to be aligned point. All right, and as we now select a third point, we can do the first assembly, the first alignment, and then it's more easier to understand how to align the point cloud. All right, let's do a first alignment. And that already fits pretty good. So let's add another point up here. And align that again. And here the fifth point up here on the building should be enough. Let's see if we can also, yes, we can also see it here in our reference cloud. So let's go to the reference cloud, select the edge, And now push align again, and it is aligned. You can see the RMS up here. So this is the root mean square error which we have between our to be aligned points. And so the root mean square error is here 207, and this is I think millimeters. So we have 20 centimeters difference as the root mean square error. All right, so we accept that, and we add the second point cloud which we aligned. As you can see, we have now already a very clearly visible view of our plane here. And now we go on with all the other locations and add them one by one to our model.